Welcome dear students. I am Rajiv Lohani. Today I would like to explain to you how images are formed by spherical lenses using ray diagrams. Before we draw the ray diagrams for the lenses, I would like to tell you some rules for drawing the ray diagrams. These rules are somewhat similar to the ones which we applied while we were drawing the ray diagrams for the spherical mirrors. The first of the rules that we have to keep in our minds is that the rays coming from infinity are parallel to one another. Number two, the rays which are initially parallel to the principal axis of the lens will pass through the focus after refraction or will appear to come from the focus of the lens after refraction. If the lens is the convex lens, then the rays will really pass through the focus of the lens. But if the lens is concave, then they will appear to come from the focus of the lens after refraction. The third rule is the inverse of this one. The ray that passes through the focus of the lens after refraction will become parallel to the principal axis of the lens. And the fourth rule for drawing the ray diagram is the rays which pass through the optical center of the lens will pass undeviated. And remember that this will happen when the lens is sufficiently thin. We will discuss only the thin lenses which are there in your syllabus. While drawing a lens, we will use a thin lens, number one. This is the optical center of the lens, and you must remember that a lens has two focal points, one on the right side and other on the left. But the two focal points are equidistant from the optical center of the lens, and this distance is known as the focal length of the given lens. I have denoted the focus on the right side of this lens by F, and to the left the point has been denoted by the letter F dash. For convex lens, the principal focus is on the right side, and for the concave lens, the principal focus is on the left, but the focal points on both the sides are equidistant from the optical center of the lens. Let us now find out how the image is formed when the object is placed in front of a convex lens of a certain focal length and is at infinite distance from the lens. As I told you in earlier video, infinite means the distance is much larger than the diameter of the lens. So the first case is this one, in which the object is at infinite distance. So let us see how the image will be formed. For drawing the ray diagram in this case, we will take two rays coming from the tip of the object, and since the object is at infinity, so the two rays will be parallel to each other. One of the rays is passing through the optical center and will go undeviated without bending. The other ray, which is parallel to this ray and is passing through the focus of the lens before refraction, will bend and will become parallel to the principal axis after refraction. You can see that these two rays are meeting at the focus on the opposite side. So what do we say? that when the object is at infinity, the image is formed on opposite side of the lens, number one. Number two, it is formed at the focus. Number three, the image is much smaller than the object, that we also call is diminished. It is real and inverted. The image is real because the rays are really meeting at this point. Now we'll discuss case number 2, in which the object is not at infinity. It is at a finite distance but beyond twice the focal length of the lens. In this case, the rays coming from any point of the object will not be parallel to each other. We will take two rays, one of them will be parallel to the principal axis. This ray after reflection will pass through the focus of the lens, and the other ray which passes through the optical center will go undeviated, and you can see that the image is formed on the opposite side, which is inverted, smaller than object, between f and 2f. This image is a real image again. What you have to keep in your mind is that the focus on this side and this side should be equidistant from point O. Similarly, the distance between f and 2f on both the sides should be same as the distance OF. And when you do it, there will be no mistake in drawing the diagrams.